Rubini. My name is Dirk Krol. I'm the Executive Director of Water Europe. And André is on his way to Zagreb for the Resurgence Project meeting. So unfortunately, he cannot be with us at this moment in time. He's still in the air. This webinar is organized under Water Europe's expert group on green, grey infrastructure and nature-based solutions. I think as you're all well aware, Water Europe's mission is to enable a water-smart economy and society where water systems are resilient, circular, climate-proof, and economically viable. And in that vision, nature-based solutions are not alternatives to grey infrastructures, but really complementary assets within hybrid green systems. A core message from Water Europe in this context is simple. If nature-based solutions are to be treated as an infrastructure, they must be managed also as infrastructure. This requires clear performance metrics, accountability, and long-term operational strategies. Nature-based solutions are dynamic living systems rather than static assets, and their performance therefore evolves over time due to climate change pressure, hydrology, ecological processes, and human interaction. However, without digital tools, there is a real risk of losing performance visibility, underestimating maintenance needs, and undermining confidence among operators, investors, and regulators. At the same time, digital innovation enables continuous monitoring instead of snapshot assessments, early warning instead of reactive maintenance, and evidence-based decisions instead of assumptions. This includes real-time sensors, IoT platforms, and integrated data streams across water quantity, water quality, and ecosystems indicators. Crucially also, it requires predictive systems, not only descriptive monitoring. So to truly scale nature-based solutions, we must move from monitoring to anticipation. And digital twins can play a key role here. Simulating nature-based solutions behavior under future climate, load, and land use scenarios, and supporting predictive maintenance and informed investment planning. This depends on an effective data fusion with ground-based sensors, operational and management data, and Earth observation data. Water Europe is actively working on this, including through a collaboration with the European agency that we have officially launched at the end of last year, with a memorandum of understanding and already a joint workshop or a webinar some weeks ago, where we tend to integrate satellite data with in situ monitoring, improve spatial coverage and long-term trend analysis, and enable scalability beyond individual pilot sites. This combination of ground data, space observation, and modeling is what turns nature-based solutions into trustworthy, insurable, and finance-ready infrastructures. Today's keynote and case studies will demonstrate how these concepts work in practice across different contexts and increasing technology readiness level. They show clearly that smart nature-based solutions are not future concepts, but operational realities. And with that introduction, I'm pleased to hand over to Fabrizio, who will guide you through the rest of this webinar. Fabrizio, please take the floor.
Yeah, thank you, Dirk. Do you see my screen and hear me as well?
Yes.
Okay, thank you so much. My name is, let me say a couple of words on me. My name is Fabrizio Lagasco. I'm from RINA, a worldwide organization providing engineering as well as testing, inspection, and certification services over a certain number of sectors. In RINA, I'm heading emerging markets R&D opportunities unit. Together with Laura Wendling, the leader, and Frans van de Ven, mentor, and other 12 experts, the expert group on green, grey infrastructure and nature-based solutions is supporting Water Europe on accelerating the adoption and upscaling of hybrid, blue, green, grey, and nature-based approaches to water management across urban, rural, and catchment environments. Its mission is to synthesize existing knowledge, promote research and innovation, and support the mainstream of NbS and hybrid systems as key tools for climate resilience, water security, and biodiversity enhancement. By integrating natural processes with the engineered infrastructure, the group works to address challenges such as climate change adaptation, carbon runoff reduction, water quality improvement, ecosystem restoration, and catchment scale resilience. It also strengthens collaboration across sectors, urban planning, rural development, river basin, and coastal management, and aligns innovation with major European policy frameworks. The expert group also contributes to Water Europe vision of a resilient, sustainable water smart society by fostering cross-expert group synergies, generating, for instance, technical and policy insights, and disseminating state-of-the-art knowledge through webinars, technical papers, and joint activities. The expert group has already delivered the webinar on landscape scale nature-based solutions for water quantity and quality management on last 24 November. Today's event is the second in the series organized by the expert group, whilst the additional webinars will be delivered later this year. This second event has twofold objective. The first is to highlight the added value of digitization as a catalyst for enhancing the sustainability, scalability of NbS-based infrastructure, explore maintenance strategies strengthened by digital innovation, and facilitate dialogue to promote collaboration and best practices in smart NbS implementation. This keynote will be introduced by Juan Luis Sobrera Seoane from ITG, National Research Center of Spain. And the second is to showcase advanced digital tools and platforms applied to the monitoring of NbS infrastructure through 3 case studies representing increasing technology readiness level. These cases illustrate how digitization can improve infrastructure maintenance, provide robust metrics, and enhance data visibility for involved stakeholders. The 3 experiences will be presented by my colleague, Federica Vergari from RINA, Italy, Sara Lepanen, City of Tampere, Finland, and Huter Igot, Hello Water Company, Belgium, respectively. The 3 presentations collectively showcase complementary real-world case studies demonstrating how digital tools, data-driven monitoring, and smart maintenance approaches are transforming NbS into reliable, scalable, and performance-assured infrastructure. Each contribute from a different domain: coastal protection, urban stormwater, decentralized wastewater treatment, but all reinforce the same core message. Digitization is the key enabler for making NbS measurable, predictable, and maintainable at scale. That said, I leave the floor to Water Europe to manage leaf pools. And we will have a question and answer section at the end of the presentation, so please write any question you have in the chat. Our speakers will address as many questions as possible during the Q&A section. Any questions not answered during the seminar will receive a response via email afterwards. Please.
Thank you, Fabrizio.
I think, yeah. Thank you, Fabrizio, and thank you, Dirk, for your opening. I will now share my screen to have a first introductory Mentimeter session. I hope you can see my screen in full screen.
No.
No.
And now?
Not yet. No.
Yeah. Yes.
Now
Okay.
it's coming back.
Starts.
We will do it like this for now, because I don't know why it's again. Okay, so
Yeah.
we can wait a couple of minutes to give time to participants to scan the QR code and enter into the Mentimeter. Okay, I think we can move on. So I will go on the second slide. Okay, so here we invite you to tell us from which sector you are mainly based on your current working area. I'm sorry. Okay. Are there any messages in the chat? Because I have
Yes.
seen that it's not working.
No, they you need to start the presentation on Menti because the questions does not appear for the participants. They don't see the.
Ah, okay, now it works, he said. Okay.
Perfect.
Okay. Ah, okay. Now I see it. Can you see it?
No.
I see it on my screen. I see the answers coming.
It's
Okay.
anyway
We
working.
will leave it like this, yeah.
Okay.
Okay, so far the majority from the sustainability sector. Okay. I don't think we're receiving some more questions. I mean, some more inputs. Okay, we can move to the next one. Here. Here we ask you to briefly share with us what comes to your mind when you hear smart nature-based solutions. Okay, So many answers from the use of artificial intelligence. The smart indicators. Okay, monitoring, planning. Okay, I can go down a bit. Okay. I don't know, Fabrizio, if you want to comment on something, if you...
I hardly see the answers, let me say. Yeah, okay. A lot of really important positions. Yeah. AI, MTOP, integrated monitoring tools, forecasting capability, remote control, using nature materials. Yeah, okay, all these are really smart nature-based solutions. So our audience is well trained and well aware of these solutions. Yeah, you
Okay,
can jump to the
we can
third.
move to the third one, yes.
Right.
Here. Okay, so here we ask you to enter a word to describe your main expectations about the monitoring metrics and maintenance.
Fast, creative, leader focus, bold, reliable, right? Yeah, it seems that the reliability is the key aspect of the smart NbS. This is really this is the challenging aspect of smart NbS must demonstrate. Let's hope that the keynotes as well as the presentation are able to sustain that feedback. Yeah.
Okay.
Even cost, challenging cost. Yeah, yes, indeed. Please, now I guess that we move on to call for the speakers to join us. Yeah, please.
Thank you. Okay. So today we have 4 speakers, and we will start with Juan Luis Sobreras Juan. So please, if you can share your screen and...
Okay, thank you very much. I'm going to share my screen. Thank you for the invitation. Thank you also to the group, expert group, to which I belong to, is the Digital Water Technologies Group. Okay, so maybe you know that one is not expert, is the result of the knowledge of other people. So I'm really proud to try to share with you all the difficulties, all the challenges that we understand in the domain of natural-based solutions and digitalization. Okay, let's start. One moment, please. Here it is. View. I have a problem with the one moment. Sure. Okay, can you see my screen? Yes.
Yeah.
Okay.
Not in presentation.
Yeah, sure. Now it's in presentation mode.
Okay.
Perfect.
Good.
Okay, my name is Juan Sobreira. One moment. Juan Sobreira, I'm Managing Director of the ITG Technology Center, it's a National Research Center located in Spain. As I told you before, I'm expert co-leader of Digital Water Technologies Group. So thank you to all my colleagues in this group. Okay. And I'm going to start. I divide these presentations in 7 points. Okay, but the 4 first ones are addressed to share with you the situation and something that it was introduced by Jörg and also by Fabrizio. Okay. Natural-based solutions, I guess, are a really nice or really interesting solution to try to mitigate the situation we have in the environment. The situation is defined by pollution, extreme events, and a loss of biodiversity. So our approach is that data-based solutions could help to mitigate or to facilitate better water resilience, facilitating mitigation, reduction of pollutions, and also facilitating the recycling of by recovering water or recovering products or contaminants or pollutants. The legislation framework is quite complex. So in this context of complexity in the water sector, natural-based solutions could help to mitigate, to face the challenge and to face the challenge behind the complexity of this legislation. One of them, I highlighted the sanitation legislation, the Urban Wastewater Treatment Directive, in which is mentioned in the natural-based solutions. It's mentioned also digitalization as a way to increase the performance of these systems. As you commented before, we must understand natural-based solution as an infrastructure, and as infrastructure which belongs to the water cycle, to the water supply, to water sanitation. And only to share with you, this is the collection of the interconnected legislative framework, which might be affected by natural-based solutions or vice versa. The other matter is, okay, we're talking about natural-based solutions, but at the end of the day, we're talking about water uses, environmental impact, water masses, and land uses. So there is there are a lot of actors behind the governance of natural-based solutions: national authorities, municipality, regions, and others. Why am I including this overview? Because at the end of the day, when we are talking about digital solutions, we should take into account the different needs of information of the different stakeholders. Okay, it's a typical concept of multi-stakeholders approach of the digital solutions. The other part is, okay, maintenance. For those of you who are working in the real life in facilities, for instance, maintenance is quite clear. And when I read what exists in the domain of maintenance of natural-based solutions planning, it seems clear. Why? Because I see or I find some documents like the guidance for using the global standard for natural-based solutions, some interesting results of European projects also. If we compare, okay, it's interesting, for instance, Reconnect project or the mentioned document from the United Nations, the purpose, the scope, the framework, it seems really clear. But if we go a step forward, if we are talking about digitalizations and at what extent data could feed the indicators, we realize that indicators are quite generic maybe, or quite far from the concept of digitalization that all of us could have. Effectiveness, address, and social challenge is really far away from a sensor, okay? The number 3 results in a net gain of biodiversity. How can we measure the biodiversity, okay? So in our modest opinion, from the ICT side, this is the summary. Okay, it's clear what the maintenance means: corrective, preventive, or predictive. But we have different challenges or different problems when we try to link digitalizations with maintenance of natural-based solutions. Why? Because it's quite difficult to identify why should I maintain something that I don't know. It's a plant, it's something natural. Why it is necessary to maintain? What is necessary to maintain? When? What are the variables behind? What are the variables that trigger the maintenance requirements? And how? For sure, we are not experts in natural-based solutions, but some of us are handling this complexity, are working in this domain, okay? In any case, an holistic vision of at what extent ICT should be coupled with the needs of natural-based solutions are summarizing in this slide. monitoring, assessment, planning and design, implementation, operation, and maintenance. So the ICT should provide support to these needs, to this life cycle of nature-based solutions, deployment, design, planning, deployment, assessment, monitoring, better understanding. How? For instance, one moment, please. Facilitating the monitoring and assessment. In the next slides, I am going to share with you the complexity of monitoring and assess the nature-based solutions. The other is real-time decision-making. One of the problems is what should we understand when we talk about real-time, okay? And on the other hand, intelligent systems to optimize urban planning and strategies. Let's see, I'm going to start the second part of this presentation, putting on the floor some, I guess, interesting insights. When we are talking about nature-based solutions, as I told you before, we are talking about urban planning. And we are talking about, for instance, a new assets that we should maintain and we should handle in the context of sanitation network, for instance. So a perspective could be the operational and strategic vision, but the other could be the policy making, to invest or not to invest in nature-based solutions, and for sure other biodiversity, economic, social, and risk assessment. I'm going to put the focus on operational and strategy, but I would like to share with you also other quite interesting related to policy making. For instance, what is the impact of investing or not in nature-based solutions? How can digital tools provide support to these processes? Okay, this could be a couple of questions behind the policy address of digitalization and nature-based solutions. But what is the problem we have to go and step forward with the policy-making point of view? Are the decision-making processes standardizing? I guess it is not, depending on the country, depending on the region. Are the metrics to evaluate defined? How to handle the stakeholder relationships and what are the strength of decisions interactions? Okay, this is the core of the problem and possibilities for sure. There are several working areas with explorative artificial intelligence, scenario analysis to compare, for example, to be active in fostering nature-based solutions against not action. Okay, this is a shot. Now let's go one step forward. Operational. Okay, let's go ahead. I would like to deploy a nature-based solution, but what is but I don't know a catalog in terms of digital of the pool of services, the pool of commercial possibilities to deploy in terms of nature-based solutions. I would like to know a collection. I would like to know the purpose of nature-based solutions. But even more, if I have an environmental risk, I would like to know how to mitigate this risk, for instance, PFAS or whatever, by deploying nature-based solutions. I don't have this information. Please, I don't have this information from a perspective, the perspective of the digital side, the digital support of these processes. Okay? Let's go one step forward. Okay, I've deployed nature-based solutions, but I would like to know the behavior. I would like to understand the behavior in terms of pollutions, for instance, in terms of water retention. How can I do this? Okay, so I split now these different aspects or visions of the operational part in different insights or different comments to share with all of you. Okay, nothing new. Anything new. I am not the expert. I am putting together the challenge that the experts in nature solutions have with the challenge that the people who are working, as is my case in digitalization, have. Are there any nature-based solutions catalog? Is there any clear taxonomy regarding classification? Because, okay, we can find several information in docs, but it's necessary to convert this information into a practical information. What data can facilitate the analysis of our performance? So in our understanding, I guess there is a lack of standardization of nature-based solutions. or at least to democratize the information behind the enormous knowledge behind the natural-based solution expertise. And what are the possibilities? For sure, if you convert catalogs or the knowledge that you have in your expert group, Fabrizio, into multi-parametric catalogs, assisted or not by natural language processing, for instance, it could be quite interesting to facilitate or to foster these matters. If we are handling, and even more, if we link the needs of public actuations, okay, public transformations with compulsory ICT system, for instance, BIM, this could be an interesting accelerator to foster the standardization of natural-based solutions. BIM is Building Integration Management, okay? Considering the same shot, definition, and selection, I would like to reinforce a couple of insights more. For instance, it's possible to identify what is the better location for a specific natural-based solution. For sure that is possible, it's complex. This means that if I have a catalog, if I have solved the taxonomy, now the next step is, here I have a problem, I would like to select the better choice or the best choice with the restrictions, because the restrictions for sure that are really, really complex or high demanding. The soil nature, the urban planning restrictions, okay? So here the idea is, okay, if we have the solved, the catalog, how can we go a step forward? How can the ICT system could support the implementation or even the planning of natural-based solutions? Maybe by using or sharing or providing decision support system to facilitate the allocation processes. It's not easy, it's a little bit complex, but it's feasible, it's possible, okay? And the other is, okay, I would like to know the impact and the behavior, because I would like to share with you, when I discuss with collaborators about natural-based solutions, the first word is complexity. The second word is be careful with artificial intelligence, because if we don't have accurate data, the model will never be accurate. The third one is be careful, because if we are talking about pollution, what is the pollution we are looking for? There is a problem of not targeting screening. And the other is, okay, I would like to know the behavior of hydraulics, or for instance, the impact downstream in our networks. This is not a fancy word. This is to deliver a sanitation model with swing or whatever you want. Okay, so at this point, I believe that there are relevant insights in this slide. Why? Because I guess we have a lot of possibilities to add value to monitoring assessment. Why? Because if you realize there are a lot of variety of sensors, but if we have sensors, the possibility to integrate sensors is already solved. It's not a problem. Variety of variables, this is not a problem. Image, data, text, spectroscopy, remote sensing is not a problem. Okay, it's solved. For sure, you have a problem with accuracy and cost of sensors. Well, you have it, but this is not a problem if we know that we have a lack of accuracy. But here we have a challenge, the combination of target and not targeted screening. But I believe that today is a problem, but in the future, it will not be an unsolved problem, because there is a trend, is my opinion, a huge work in the domain of new and innovative sensors. Okay, but in any case, what are the challenges? How can ICT, at what extent ICT could provide support to assess the impact of natural-based solutions and the behavior? For instance, facilitating the data infrastructure, data lakes, data space, to handle the data and the life cycle of this data, okay? And to provide advanced data treatment techniques to overcome, for instance, not targeted screening analysis, okay? Okay. And now if we put the focus on modeling, what modeling must embrace? Because many of you have included the concept of artificial intelligence. For sure, it's interesting in artificial intelligence, but it's not only the only technique that we would like to put on the floor, okay? And in fact, what happens when we are talking about short-term and long-term, the techniques are quite different, okay? For instance, if I would like to analyze the impact of a huge natural solutions in climate change, the analysis techniques are quite different, okay? So I would like to put on the floor that we, or you, should work together combining numeric modeling, hydraulic modeling, for sure, with artificial intelligence, okay? Something is missing here. Here it is. Yeah, I am sorry because here.
Yeah, if you can conclude, Juan, we have 10
Yeah,
minutes.
okay. I conclude, yes. Here you can see this is a typical model based on SWIM, okay, traditional modeling, and the other is an example of artificial intelligence. But you should to be careful with the accuracy of the artificial intelligence models due to the lack of accuracy of the sensors. And to conclude, okay, natural solutions are already part of the water management systems. Okay, natural solutions embrace different governance structures, and the impact affects a wide legislative framework. There is a need of standardization to facilitate the management and the performance understanding, and beyond the complexity, digitalization provides support to urban planning and policy making and operation maintenance. How? Providing identification and allocation to face a specific purpose, monitoring to facilitate performance analysis, numeric artificial intelligence and every modeling to facilitate a better understanding, a decision support system to foster knowledge sharing and multi-stakeholder analysis. This is my vision. I sorry for this 2 minutes beyond the planet, and open to any question. Okay, thank you very much.
Thank you a lot, Juan Luis, for this complete introduction of the role of digital innovation for scaling NbS. And now we will focus on 3 different study cases. And the first one will be introduced by Federica Vergari from RINA on smart NbS for coastal protection. So,
good morning, everyone. Thank you for the presentation and thank you for joining this webinar. Let me share the screen in the presentation mode. Let me know if you can see.
Yes.
Yeah.
The card. Oh, okay. Perfect. So my name is Federica Vergari and I'm a smart infrastructure monitoring engineer at RINA Consulting, where I work in the asset monitoring team. Today, I want to discuss how we are building a smart society through the integration of nature, engineering, and digital innovation. So nature-based solutions, or NbS, are becoming an increasingly important for enhancing climate resilience. We are in a kind of revolution, the middle of a kind of revolution from the traditional gray infrastructure to the green solution and now to smart solution. So this means that nature-based systems are turned into a digitalized infrastructure that integrate the sensing, data, and modeling to enhance the long-term resilience. So a key concept here is that the resilience is more than resistance. So to make NbS truly adaptive, we need to understand how they evolve over time. This is where digital technologies come in, enabling us to monitor, model, and adjust these systems dynamically in response to changing environmental conditions. So we are coupling biomaterials with digital sensing by embedding sensors into NbS, creating a kind of digital twins for predictive maintenance and integrating also, for example, remote sensing or IoT or artificial intelligence. So when we talk about sensing in NbS, we have specific measurement requirements. On one end, the real-time mapping over the extensive structural areas, and on the other end, the acquisition of local environmental and mechanical parameters for comprehensive system understanding. So all these requirements drive our choice of sensing technology into fiber optic sensors, DFOS, which are innovative sensors enabling detailed monitoring of NbS. They are used for a lot of applications, such as for structural health monitoring, predictive maintenance, or urban greening, and so on. The main feature include distributed sensing of the strain, to the detection of, for example, the temperature profiles, or a lot of these characteristics. But how do they work? Optical fiber transmit the light signal through a transparent core, guided by the total internal reflection of the light. So local changes in strain or temperature or in the geometry of the core alter the light's properties and enabling highly sensitive measurements along the entire length of the fiber. So we at RINA, now we are implementing these technologies in several European projects for coastal protection. For example, in Operandum, a project of many years ago, we worked to mitigate the hydrometeorological risks through the NbS, offering a scientific proof of the NbS effectiveness and establishing best practices through stakeholders' engagement. Similarly, now in a project where I am involved in, Regions for Climate, or R4C, we are addressing climate change challenges with a citizen-driven approach, fostering inclusive and resilient regional ecosystem through cross-sectional innovation. So let me focus on R4C, Coastal Dune Case of Study, where we are working in a Gulf of Follonica in Tuscany, in Italy, within the Steppaia Coastal Park. This area suffers a lot from significant coastal erosion and extreme storm events. So nature-based solution and intervention have been carried out for years to protect the coastal dune system and to rebuild the coastal dune system. So we designed a restored dune system developed through bio-based NbS as a nature defense against the coastal erosion and extreme event. RINA developed an experimental digital monitoring solution based on embedded FOS, fiber optics, integrated into a dune through a geotextile, so a bio-based sensorized net. We called it BioNet for simplification. This innovation has a dual purpose. It reinforces on one end the dune, and on the other end, we can use this technology to capturing the strain along the structural direction. So the R4C project follows a structured three-phase progression. So we have a phase one involves the lab characterization of the BioNet's mechanical properties, and at the same time, an optimization of the fiber integration method. A phase two that we carried out in order to validate in a field scale the system. And finally, the phase three, during that we did the operational installation on the demonstration site. So in phase one, we performed tensile tests on a bare BioNet in order to estimate the Young's modulus and the elasticity of the bayonet, and some tensile test on the sensorized specimen. During this test, the key variables have been tested, including, for example, the variation of the sensor response under the different loadings, or different kind of adhesive types have been used, or different anchoring method, for example, of the fibers. All these tests in order to understand the best configuration of the technology. The tensile tests were monitored in real time by using an interrogator system, which records real time the strain distribution in microstrain along the optical fiber. So the data acquisition was synchronized with the mechanical loading that we applied with the mechanical machine, enabling detailed analysis of the fiber's response to increasing tensile forces. So through this iterative optimization, we were able to identify the optimal configuration of sensors, so the fiber type, installation method, and the type of adhesive to install the fiber on the bayonet. During the phase 2, once we determined the best configuration, we did a lot of large-scale laboratory validation. The sensorized bayonet was mounted on a tractor bucket to create dynamic loading scenarios simultaneously in real field condition. So we performed a soil erosion simulation test where Raven was subject to repeated rotational steps to simulate the landslides and the erosion process. During this test, 3 kinds of samples have been tested depending on the orientation on the bayonet. So different fiber orientation have been tested. So we had some sample with the orientation along the vertical direction, so the wrap, or in the horizontal direction of the weft of the bayonet, and the third configuration, a mix of weft wrap configuration. So after the experimental results analysis, we decided to choose the weft wrap configuration, so the mixed one, in order to maximize the sensor coverage and the sensitivity. So after choosing the best geometry of the sensors, the phase 3 was the actual demo site installation in Piombino. So the site preparation involved adjusting the dune structure for optimize the bayonet placement. The sensorized during the installation was installed along the dune slope and protected by the connection protection by using a waterproof boxes in order to protect and ensure the connection after the installation in the sand. And the first preliminary tests were carried out in order to understand and to confirm, to verify the proper functionality of the fibers after the installation on the demo site. So the next steps will be to monitor during the next 2 years the strain and the evolution of the profile of the dune after extreme storm events. Here are some images from the site during the installation of the bayonet on the sand on the dune. Here the artificial dune rebuilt after the end of the demonstration site. And finally, we have defined the key performance indicators for real-scale coastal application. So to evaluate our system's effectiveness, we have defined 3 main categories of KPIs. From a technical perspective, we target strain measurement accuracy within plus minus 10 microstrain, the spatial resolution under 10 centimeters, and we set the sensor durability exceeding 5 years in a rush environment. Environmentally and structurally, from this point of view, we aim for measurable dune stability improvement and failure prediction in order to have a minimal impact on local biodiversity. And finally, our operational targets include a 95% system uptime during the storm event, minimal maintenance, and less than one of intervention per year, and cost effectiveness, keeping this kind of monitoring cost below 10% of the total NbS implementation investment. So thank you for your attention, and I'm happy to ask for any question you may have.
Thank you a lot, Federica. If you have any question, don't hesitate to put it on the chat. So now we move on to the second study cases, which is presented by Salah on smart NbS for flood prevention and stormwater management.
Thank you. Good afternoon. Can you please share my slides?
We don't see the screen.
While waiting for this new screen from you, Salah, I trust on you and Wouter to save a few minutes because we are a bit late.
Okay.
Can you see the screen?
No.
Do you see the screen now?
No.
No. We see you now.
I don't know why I'm having trouble with the screen sharing. I don't know, Tiffany, if you can do it, because I don't know why it's not working. It say that anytime I try to share, it say that it's in pause, and there's no way I can unlock it. I'm sorry for that.
Sorry, we just need 1 minute.
Okay, I can maybe start telling about myself. Good afternoon, everybody, and I am Salla Leppänen, and I work for the city of Tampere as a stormwater specialist. And thank you for the invitation to this webinar. I am happy to be here today with you. And waiting for the slides.
Okay. It's coming. Sorry, huh?
Great.
Perfect.
Okay.
Okay. Can we have slide number 3, please? Next, please. Yes, thank you. In Tampere, we have a stormwater concept that works effectively in flood prevention and stormwater treatment, and it's also reliable in changing climate. And the performance of this nature-based stormwater system has been monitored with real-time sensors. And in this presentation, I will give a quick overview of the topic. Tampere is the third largest city in Finland with 260,000 inhabitants, and we have 160 lakes within our municipality. Most of them are small and shallow and cannot therefore tolerate too much pollution. And therefore, proper wastewater and stormwater treatment is very important for us, and we have implemented already around 100 nature-based solutions for stormwater treatment and retention. Next slide, please. Climate change is challenging us. It is predicted that in Finland, the annual precipitation can increase up to 30% by the end of the century. And in the meanwhile, our city is getting denser, growing, and this means more stormwater in the future, also more floods, pollution, habitat loss. But we are actively tackling the challenges that we're facing with nature-based solutions. Next, please. Case area Vuoret is a pioneer site for nature-based solutions in Finland. It is one of the largest NbS sites in Northern Europe. And this used to be a greenfield area and has been turned into a city district for 13,000 residents. The construction of the area started in 2008 and it was finished in 2022. And this area used to be fields and forest and peatland, and now it is a city district. Next, please. And the stormwater concept consists of a decentralized system. This means that we have treatment and retention for stormwaters both in private areas, private plots, and also in public areas like parks. And in this image here, you can see that the stormwaters from plots are directed to cleansing swales that are in a park, and then the stormwaters are filtrated there, and then the overflow is directed to stormwater pond and wetland area. And requirements for property-specific stormwater retention were set in zoning plan. Next, please. And when we were planning the system, our objectives were to prevent solids and nutrient load to waterways, and also to regulate regulation of flow rates to the pre-construction level of the area. It's many sensitive lakes and streams there, and we wanted to protect them and also avoid flooding. And these goals were met with floodplains and constructed wetlands, green swales, etc. Different nature-based solutions that were built to private areas and also to public areas. Next, please. And the performance of the system was monitored with real-time sensors and also traditional water sampling, since all the important parameters cannot be monitored with real-time sensors. And our goal was to evaluate whether the system achieves the qualitative and quantitative goals that were set for it, and also to assess the effects of the construction. We expected this construction to cause some pollution for the small lakes there, because some massive soil exchange was needed, because the area was partly peatland and you cannot build apartment houses on peatland. And since there are many inlets to the system, we decided to compare the outlets of the system to the pre-construction measurements that were done at the same spots. Next, please. And we found out that nutrients and solids were at their highest during the earthworks, during the massive soil exchange, as we expected. The concentrations were about or more than 10 times higher than pre-construction era. But after the construction, the concentrations have been lower than they were before construction. So this nature-based stormwater system is efficient in pollutant removal. And the flows were significantly higher before construction than they were after construction. And there is some error in pre-construction measurement because the flow rates were estimated before construction visually based on experience. So these results are not so reliable. And during and after the construction, the flow rates were measured with real-time sensors. Anyway, some hydraulic modeling has also been performed, which shows that the retention capacity of the system is good. And we have achieved the qualitative and quantitative goals that were set for the system in the planning phase. And we are replicating this Vuores stormwater concept in other new city development areas. Next, please. And also, based on Vuores experiences, we have expanded the smart water monitoring system to cover the entire city. We have implemented 35 real-time water monitoring stations in rivers and stormwater sewers. We are monitoring turbidity, conductivity, flow, water level, and temperature. And also we have some monitoring stations where we monitor rainfall and snowfall. And this monitoring data is transferred to cities' IoT platform, where the experts can view it. At the moment, it's not available for the public, but maybe in the future. But there are these safety issues and how the situation in the world is at the moment. So we are not able to share the data with the public at the moment. Next, please. And then when we think about the benefits of real-time monitoring, we have already heard about it, about the benefits. I have listed some here. And I think it's very important that our decision-making is based on evidence. We know where we have problems with water quality and quantity, and we know where to target the actions. And since we have limited resources. And also we get important input for stormwater planning, for dimensioning the stormwater systems, and also for stormwater modeling. And then our maintenance is also based on evidence. For example, we can see if there is some clogging in our stormwater sewers, and then we can send the maintenance department to check or flush the sewers, for example. Then we have been detecting wastewater leaks. It is quite common that wastewater enters the stormwater sewers or streams due to faulty sewer connections or overflows. And we can then detect these with these real-time sensors. And next step for us is to develop machine learning-based prediction models for flood protection for certain streams that have problems with flooding, and there have been some damage to the properties. Next, please. And I would like to conclude here that a decentralized nature-based stormwater management system is efficient and reliable. Since we're not depending only on one single system, but we have many across the catchment area. And this smart water monitoring system, it supports decision-making and makes us better adapted for climate change. Thank you for listening. This was everything from my side.
Thank you, Sara, for this. And for the time remaining, we have the third study case with Wouter on smart NbS scalable and decentralized wastewater treatment for flood prevention. We are going to share the screen with her.
Thank you. Hello, everybody, from the coast and stormwater to the mainland of Europe, and a vision. And Fabrizio, I will take it short and stay on topic. I will try, and the jam session is for another time.
Thank you so much.
Some insights to start. Can you share my presentation? Okay, I will start with some insights. The main question in the water crisis now is what water really works, and where we can meet landscapes and new needs. And the vision of Hello Water is a question, is sewage the right solution? You can go further on to the next on the presentation. Yes. Is sewage the right solution, knowing that at the moment there are about 50 million European citizens do not have any form of sanitation and living in the European landscape. So from that on, Hello Water sees, and everybody sees, water as a vital resource, very essential to economic development, food security, and life itself. With that in mind, it took me 15 years to develop what we are having now, a modular wastewater system, possibly powered by renewable energy and real-time steered on a data platform. And everything is designed for reuse in a kind of 3 claims. You can go to the next. We have a different looks and feels. We have mobile wastewater treatments. We can build solutions on top of roofs, but everything is source-based. Some claims that we make is that the water needs to be reusable, but also every form of material we use needs to be reusable. So we are at the start here in the presentation to a modular system, and the concept of it I will show you. Go on, please, to the next. In a modular setup, you can receive the wastewater from households in a pre-settling tank, and it flows to a treatment wetland, and the treatment wetland is modular. So we can operate it in function of time, in operation of time. If there is something changing at the number of households, we can click it open and put some modules in it. The security about certification is also made visible. We are building to European standards, and we are trying to meeting from that standards on, from a building perspective, meeting to the results of the needs described in the new urban wastewater directive from Europe. So we have a lot of steps, and the last step is our new FOSCube, and that's a tertiary, the third treatment to polish on nutrients, on other. Sorry, I lost the word. Go on to the next. But nature-based has some 3 of a kind, and I really want to mention it: the good, the bad, and the ugly. It's with a smile. The good, in my opinion, nature-based systems delivers a strong and reliable performance, but it's less known for everybody at this moment. The bad, every gray infrastructure in the landscapes is a hard material. And also in the bad, nature-based doesn't mean carefree, but you have to know what the care needs. And the ugly, it's with a gimmick. There is a mind shift needed for people who are used to traditional gray, but you see on the picture a green infrastructure in front of a row of houses, and with some participation, people can choose their flowers, choose their colors, and meeting participating trajects. Go on, please, to the next. I'm running through time, but removing the bad and the ugly, we developed some modern management tools, including real-time water quality sensors, online data models, and we are growing from a Hello Water perspective to combine the technology with boots on the ground to a financial asset, to sell the results, to make the results visible, and post-treatment steps for phosphor and more. And we need to have a robust technology designed as a scalable modular system. So with the three claims, reuse to revaluable materials. And that's in the system at the moment. As you see on the next, we are future-proof, in our opinion, in urban planning. The urban directives, we are meeting the numbers needed from urban wastewater directive on a local scale. So we are at the picture you see, we are very, very source-based, and some benefits of that is that we also achieve to have a temperature that we are receiving. So the uptime of the system during winter is higher. And we developed some patents about sustainable treatment materials, and a little on the smallest picture, the newest systems are fully solar powered. So off-grid is not an option, but it's real. Go on to the next, please. From asset management, the mostly known is the basic management, technical parameters, pump, weather monitoring, energy, but we combine some extended management in water levels, water quality sensors, and real time. But saying this, I prepared for this expert group on the next slide a QR. And what about talking about real-time monitoring? Everybody has now the opportunity to feel the monitoring. You can scan the QR and go live on our platform, Internet of Things, and whatever. You will see and feel it, how we manage to steer, to monitor assets and systems, wastewater treatments. So it's transparent, and we have some regulations, some technical stuff. You will see and feel it by yourself. By the way, if you have questions, you can email me always. I don't know if everybody, how much time I have to calculate for everybody has the opportunity to scan the QR, but if we say now is a good moment to round up, you can go to the next. We see from Hello Water a kind of benefits in what we achieved at this moment. We have a high uptime of 97%. We deliver solid management, but solid results. And that's my main passionate topic. We have to see results in our landscapes on Flanders level, on European level, and meeting new combinations in the roles of landscape, the roles of households, and the roles of cost. So that's it. You can see monitoring as a share of a CapEx. It's common sense, in my opinion. Some digits about Flanders. At this moment, about 340,000 persons without any form of sanitation, and we are making a gimmick to the carbon from a sewage system to a local wastewater treatment. And in the building materials that we use, we can achieve, on Flanders scale, about a decrease of 180,000 tons of carbon. If you want to the next, Fabrizio asked me more than one time, I think more than 6 times, Wouter, can you share something about insights about costs? From a pragmatic view, in our opinion, nature-based doesn't mean it has to be the cheapest one. The investment is quite something, but if you look to the sewage system is only a transport system, doesn't achieve any form of purification, and brings the water away from the rural areas of the peri-urban areas. So, in our opinion, based on real data about money, in a one-pager, and a view on costs and what's achievable. But next to costs, I mentioned prestations or results. You can go to the next. Every result has a form, has a legislation in urban wastewater treatment directive. We have some new parameters, not new to the environment, but new in the legislation about phosphorus, about nitrogen. So on a local scale, we are ERSA compliant, urban wastewater compliant to the Flemish regulations. On a local scale, to the highest level of wastewater treatment plants. So we can fully compare what's the cost of a wastewater treatment as a system and prestations, meeting that on a local scale with a lower investment, but the highest prestations possible at this moment of time. And ending with a top view from the air, please, the next slide. It's possible to implement all this modular infrastructure. And with the new quote, Hello Water is developing nature as an infrastructure in the landscapes. And the first benefit is the landscape, the biodiversity, the life itself after the system. So with a passion for water and financials, I will round it up, remembering that time is costly for everyone. Thank you.
Thank you a lot, Wouter, for this. And thank you to all our speakers today. Since the webinar is mostly coming to an end, we can take 5 minutes to answer questions. And I've seen already one in the chat for our speakers from Simone Guazotti. I guess, what is meant by NbS multi-parametric catalog? Describe each solutions with a list of parameters which can support decision-making, suitable environmental conditions, co-benefits, performance, etc. Thank you.
Yeah, I guess this is a question for Juan. Is it still there?
Yes.
Yeah. Okay.
Okay.
Yeah, multiparametric is not only, one moment, please. I have to close the door. Multiparametric is something that is not only applied to nature-based solution. Okay, something which might be defined with several parameters. For instance, if you are talking about nature-based solutions, imagine that you are talking about sustainable drainage or artificial basins or others. Okay, a first general classifications of nature-based solutions. The other could be, okay, this nature-based solution is more suitable to avoid or to facilitate the pollution retainment, okay? If you realize you have a lot of possibilities to try to identify all the possibilities of one nature-based solutions. Other could be if the vegetation is a local vegetation or no. The other could be the substrate, the soil. Okay, so there are a lot of parameters. Okay, so there is a lack of, not a lack, because on one hand you can find a lot of information regarding the different types of nature-based solutions, but unfortunately are in text, okay, supported. So you want to add value to this information, it's necessary to go one step forward to classify in a classified database and to facilitate the use. What does it mean to facilitate the use? For instance, to adapt the language in which each end user looks for a solution. It's different. The vocabulary, the taxonomy of one policymaker is different. The vocabulary that a civil engineer could use or is different. The vocabulary that a water utility management can use to talk about the same database solution. This is the summary. Okay.
Thank you a lot, Juan Luis, for your answer. And we just have one other question from Nila Medina in the chat. He's coming from the Global South, and he asked for one key take-home messages for him here in the South to successfully implement NbS, if you have any advice.
Yeah, I guess that the colleague is specifically mentioned about NbS that work in water scarcity condition, and probably where the technology is not so well, let me say, distributed or available, and so on and so forth. So let me say first is indeed be able to select which is the most performant NbS without any measurement, and then try to be much more focused on what we measure. In principle, save as much as water as possible, and taking the, let me say, the need of technology support at the minimum. This could be, I guess, but even one may say more, could be to address, for instance, space-based assets monitoring capability. But from time to time, it's real that also on-site sensors are necessary to measure to be so accurate.
Thank you. We have a last question, and then we will end this from Paolo Franceschetti. Have you monitored the concentrations of emerging contaminants after an NbS treatment? Have any benefits been observed or else?
I guess that the water is the guy, in the sense is putting sensors in his, let me say, constructed wetland, measuring pollutants before NbS treatment and after to make sure that the the directive is indeed guaranteed. Directive requirements is indeed guaranteed, and also is really putting this data available to the stakeholders to increase reliability and trustness of these stakeholders. Yes, indeed, definitely.
Can I answer, or
would you add something, Guta? Would you like?
It's a very interesting question about concentration, emergent contaminants. Yes, I only showed the aspect about phosphor, but there is a lot more of emerging contaminants. We are following it up at the moment, but we are also having some patent pending about the developments of Hello Water. We have matching numbers about heavy metals. We have matching numbers about pesticides and pharmaceuticals, but I wanted in this room to show what we achieved and what's commercial available at this moment. But in the very next phase, we can add on the FOSS cube another polishing step, another treatment step, or combine it in the same one that's made just for the emerging contaminants. And that's very, very hands-on with a lot of data, but also with a digital twin. but maybe that's for the next one. So we have to grow in time also. But we will present something further up this year. I think about April or May, we will present the results in a publication, what we are meeting now in meeting that question.
Thank you a lot. Well, thank you to all of you for coming to this webinar. We hope to invite you for another one, and we will keep you updated on Water Europe website on new webinars coming up. Thank you, Fabrizio, for putting together this webinar on NbS. And I don't know if you have a last thing to say.
Yeah, thank you so much. Actually, it was very sorry for being so late, but it was really insightful. Let me say, we have got different sections, very technical, but let me say, starting from the beginning, I was aware about the three main, let me say, gaps. The lack of high resolution long-term monitoring on NbS performance, limited quantification of NbS health, behavior, and failure mechanism, and as well insufficient operational models for maintenance, asset management, and life cycle performance. Now, thanks to this feedback, let me say, I'm much more aware of that. And I hope that also the audience is as really appreciated, and let's go on more reliable NbS, as we said since the beginning. Thank you so much.
Thank you. Well, have a nice day, and we can end here. Thank you.
Thank you. Bye.
On the next
Thank
webinars.
you. Bye.
Bye-bye.